This is an Excel demonstration of how you would use a t-distribution cumulative function to determine a particular probability of a certain statistic, if you want to. Now, you have many ways of doing this, but one of the ways that you can try is to evaluate the t-distribution based on a standardized statistic. And what it means by a standardized statistic is your standard deviation needs to be 1 and your mean needs to be 0. But remember, it's not always the case that your mean is 0. Now, you can have a particular, like this is the thing that we did last time. But let's say that as we said last time, we had an n equal to 5. Now, the usual problem that we have, let's say that we get the heights of individuals in a classroom, and their height was, let's say, 170 centimeters, 165 centimeters, 172 centimeters. These are for males, by the way. 160 centimeters and 180 centimeters. There's 5 of them. Now, if you get the mean of this, and I hope I can do it. So I grab my calculator to help me out. So I have 170 plus 165 plus 172 plus 160 plus 180 and divided by 5, and I got 169.4. So that's not 169.4. That is not a zero mean. So this is not standardized. This is not going to be a standardized normal distribution in that case. But if you want to standardize it, then what you do is you need to get the particular z-score of that particular mean. But if you don't know how to do it, then I suggest you just use the values that you have. But the problem with using this mean is you also need to determine the standard deviation of the sampling means, and don't forget that you can get it by knowing the standard deviation of the population all over the square root of n. And remember, the sample size in this case is 5, so that's sigma all over square of 5. But the problem in this case is you don't know the standard deviation of the population, and the only thing that you have is one sample. So what you can do is you can approximate the value of that from the standard deviation of the sample. So you can approximate, as said, the value of the standard deviation of the population to the value of the standard deviation of just one sample. So that's a very crude approximation, but it works all the time. So you need to do that, and the way that you do that is for you to use a formula. S is equal to the sum of each data minus the mean. Alright, and it needs to be squared. But this thing is all over n minus 1. And when we do that, because we're using a sample, we don't overwrite n. If you're using a sample, we use n minus 1. And you take the square root of that, and that would be that s. It's an approximation for the sigma p. And now that you have the sigma p, the approximation for the sigma p, you plug it in there, and then you solve for this problem. Alright, let's see what I get from it. So I will just be using a calculator to solve each one, and let's see what I get. I end up using Excel because I noticed that the calculator might take a longer time. So those are the values that I have: 170, 165, 172, 160, 180 right here. So let's focus our attention. Let's focus our attention on these guys right there. Alright, so let's see now. So I can get the sample standard deviation, not the standard deviation of the sampling mean, not that, just the sample standard deviation, which approximates the population's standard deviation. So I can do that by typing in stdev, and you can see that you can choose P or S. So you choose S, that's for the sample, and highlight these guys, and close parentheses, and that's it, 7.53. So let's just write it down here, 7.53. I think it's a 6, so 7.54. Alright, so it's 7.54. So those are the things that we need And let's go back to our Excel. So now we know that our mean is 169.4, sorry, and the standard deviation is 7.54. The degrees of freedom, since we have number of samples to be 5, and so the degrees of freedom needs to be 5 minus 1, right? So it's 5 minus 1, so that's equal to 4. That's the degrees of freedom right there. Alright, that's good enough. Now, what I need to do is to fix this X statistics, because I know that the mean is 169 and the standard deviation is 7. I need to start at, as you can see, this is 3. This means 3 standard deviations to the left of the mean, right? This is what it means, because this is standardized. 3 means how many standard deviations away I am. But in this case, what I will do is for me to know, okay, how many is 3 standard deviations? It's 3 times 7.5, or 3 times 8, maybe 24. So I need to start at 169 minus 24. So let's see, 169 minus 24 is 145. So I will start at 145 and just gradually increasing maybe by 5, so 150. And then I'll just increment that, and I'll just go down and see what I get. So I get 145, and right until it needs to be plus 24. So 169 plus 24 is around 193. So let's see if I reach 100. It goes beyond 193, so that's good enough. So the point is, I wanted to plot the t-distribution and also the t-cumulative. But how do I do that? Remember that in the case of the t-distribution, you needed to plot the x statistic, and I also need to plot the mean. All right, what's this? The DF, sorry, the degrees of freedom, and also I need to specify false for the t-distribution. Alright, for the cumulative, if I want to get the cumulative, the only difference between this and that is I said true if I want the cumulative. Now notice the problem is it becomes so small, like the values are so small. And the reason for that is I don't really need to change this. Like you might be thinking, do I really need to change this X statistic? Alright, that's a good thing about t-distribution. You don't really need to change this X statistic, because the t-distribution being used in Excel depends not on a family of normal distribution, but only depends on only one thing, which is just the standardized normal distribution. So remember that 145, if I draw it in, if I show it to you where 145 is, so in our case, yeah, there's nothing wrong with it. It is still a t-distribution. But what it shows is we know that we have 169 on our mean, and this is 145. This 145 is actually three standard deviations away on the left, so that's minus 3 standard deviations away from the left. And 100, what did I say before? 193, I believe, 193, yeah, is 3 standard deviations away also, because it's 8 times 3, because 8 is the standard deviation, times 3 is 24. So you can see that this is what we need. We need negative 3 and 3. So let's just go back and change it to its standardized form, which is negative 3, and just increment by 0.1. So I'll go and change it back, double click, and see what we get. Alright, if we look at the graph right here, so I just changed it back to the standardized form. If we look at the graph, we get a really nice t-distribution again, with really thick tails and a much lesser steep peak. But also what we need is the cumulative distribution, so we can just go and plot it. If you wanted to plot it, you need to press right click, select data, and you need to remove this. Let's remove this. All right, we don't need that. And let's just check if the t-distribution is actually correct. Alright, you can press an edit and just check if it's giving the right thing. X values is the green ones. I think that's correct. The y values is this. Alright, that is wrong. That is not the y values that I need. Let me just change it. So for change it, you need to highlight and remove, and then you need to highlight exactly where it starts. Now, usually the problem is the graph is on along the way, so you just cancel if that's the case. You just go cancel and make sure that that's not along the way. And as I can see that this thing didn't take the true value, so you double click on that, so everything becomes a true value right there. Alright, so I think I fixed the graph, and here's the graph right here. The yellow one is the let me just fix it. So right click, then select data. That's not the normal distribution now, that's actually the t-distribution. Press enter, and the t-distribution actually the cumulative. Just press cumulative distribution. That should be double M. That's fine. Alright, cumulative distribution. As you can see, we have the same result as the normal distribution. Looks like a sigmoidal curve. And if you wanted to determine a specific statistic, say, what do you want to determine? Let's go back to our analysis. So let's say that we wanted to determine the probability of getting a height, this height, the probability of getting a height of, let's say, 180. So how are we going to get a height of 180 based on the statistics, based on the Excel? Well, we need to get the t-statistic of that. So if our mean is 169, then that's 180. So let's see, 180 minus 169 all over 7.54. That's the t-statistic. And remember that this is the statistic, this is the mean, and this is the standard deviation of the sampling means based on the sampling distribution. And this thing is the statistic, just xi right there. So let's grab my calculator. Let's see what I get. It's 180 minus 169, I think 0.4, I believe, equals divided by 7.54. So the t-statistic is 1.4. 1.4. Let's write it all down. 1.4, and let's go back to Excel. Let's see where 1.4 is. I believe it should be around here. So if we put our cursor, let's just go down. There we go, 1.4. So the probability says 0.88. Let's go back to our analysis. The CDF gives us 0.88. But where is that 0.88? Remember that the cumulative distribution gives us from negative infinity to the number. So this is the thing that is 0.88. But if we wanted to get the one on the right side, this part right here, if you want to get that, it's just 1 minus 0.88, and that gives us 0.12. Or the probability of having a height of 180 based on this distribution, and taking this as the mean value, if that is the mean value based on the sample, then the probability of getting 180 is equal to 12%.